look at how we're going to get there and take a step back and look at the low-level stuff. So, first of all, if you're going to be involved in doing RESTful web services, I think it's pretty important that you have a good understanding of HTTP and what it is, what it does, how it works. Thankfully, HTTP is a fairly simple animal. You might think so because it's a request, you get a response, you're done. It is, it's really simple. But there are 2 or 3 pieces to each request, or 3 or 4 pieces, and a few different pieces to each response, and it's quite important that you understand what happens. So, HTTP is a data transfer protocol designed from the ground up for distributed use, so that's good, that's what we're trying to do. We're trying to build systems that are distributed across multiple platforms. Obviously, we all know it's the foundation of web communications. Browsers and web servers use HTTP. Most web services use HTTPS. I probably should take the brackets off there. If you're hosting a web service, you want to be using HTTPS. And if you're interested, all the specs for HTTP are quite interesting. They're going to walk you through exactly in detail what it is I'm going to be talking about today. But the RFC numbers, the request for comment numbers of the HTTP specifications are there if you want to go and grab them and look at them. In essentials, it's pretty simple, and I've already mentioned, there's a request. Everything starts with some client device. The server's just sitting there doing nothing. Well, it might be dealing with other client devices in a multi-threaded way, but essentially, as far as I'm concerned, my server that I'm about to talk to over there is just sitting there on the internet and it's waiting. And some client decides, I want to interact with this server. So the client is going to formulate a request, okay? The client then will make a connection using TCP/IP to that service. It will send that request. The server will say, oh, someone was talking to me, receive the request, take some action based on what the content of that request are, formulate some response. That response may or may not include data as such. There will be some data that comes back, but it might not be application data. It might just be, yes, I did that. Or it might just be, yeah, I deleted that. Or I don't know what you're talking about, or there was an error. Or it might be, here you go, here's a bunch of data about that order that you asked about. Okay, so there may or may not be application data in the response. So the client makes a connection, sends a request, server executes it, sends back some response, and disconnects. That's it. That's the end of an HTTP interaction. Anything beyond that, as I mentioned, is application specific and implemented in some way to make it look like there's an ongoing session. So what does an HTTP request look like? Well, there are 3 primary parts to an HTTP request. If you've ever done HTTP API in Synergy and looked at the log files, you'll be familiar with this because the log files are the actual HTTP request and response that get sent and come back. So if you've ever looked at those log files that HTTP client GET creates, for example, that physically is an HTTP request and response. So the 3 parts of a request are, there is always something called a request line, okay, and that is essentially identifying what are we asking you to do. There is always a section of request headers. Headers are name-value pairs. We'll talk a little bit more about headers in a moment, but typically they provide additional information. And then there may or may not be a request body, and that contains any data that we want to send. And visually, this is what it looks like. This is literally what an HTTP request looks like. The request line basically is, what are we asking the server to do? This is literally the first line of text that is sent to the server over the connection. And it has 3 parts. The first part is the HTTP method that we're asking the server to use. Okay, there are several, there's 12 or so, I think, methods. 2 of them we use frequently when we're dealing with web browsers as a human, or when we're dealing with older style of web services, we tend to deal with the same 2, with SOAP services, get and post. So physically, the first 3 or 4 characters of the request line will be get or post. A get, we're trying to retrieve something from the server. That's what a web browser does. If you type in a URL, www.google.com, the request line says get/home or google.com or whatever it is. We're saying, please send this resource to me. Okay? A post, you're sending something to the server. Okay? So that optional body that we mentioned a moment ago, with a get request, there is no body. You're simply saying to the server, please send me this. With a post request, you are sending data in the body to the server. So you might be creating something or updating something or filling in a form on a website. You hit that post button, it's sending data from the form in some format back to the server through the request body. The second part of the request line is what's called the path, and that is usually a path on the server. It might be a slash, the root document, the root element, whatever service is at the base URL, or it might be slash hello, it might be slash default.htm, it might be slash orders slash company ID slash 57 for order 57. It's whatever the resource is that you're trying to receive. Again, in a web browser, that resource is the URL of a file on the website, an HTML file. The server simply reads it off the disk or out of the cache and sends the content back to the client. And the third part of the request line is the HTTP version. For years and years and years now, it's been 1.1. And pretty much the entire web is operating on HTTP 1.1 at this point in time. HTTP 2.0 is just in the process of being formalized. So you might start to see HTTP 2.0 sites operating. Almost everything is HTTP 1.1. So we're saying, this is what I'm asking you to do, the type of operation. This is what I'm asking you to do it to. And by the way, I'm using HTTP 1.1. And then this line is terminated by a carriage return line feed. There's an example of a request. So get API customer number. You can probably guess that I'm asking it API. I'm talking to some kind of API. Slash API is kind of a convention in the web API world. It's not required, but a lot of web API services start off with a slash API part to the path. Slash customer. Oh, I'm trying to get a customer. Oh, there's a piece of data. That's probably a customer ID, right? I'm saying to the web server, please give me this resource. Okay, and I'm doing a get, so I'm not sending any data in the body. I'm telling it I'm using HTTP 1.1, and that's the end of the line. Then we move on to URI parameters. It's possible within the URI to send additional data if you wish. Again, you've all seen this happening in web browsers. The point is there's multiple ways of doing it. You can actually use query string parameters. So this, for example, is saying, here's the end of the resource identifier, and here's the beginning of a query string. So ID equals value. And a query string is just one or more name-value pairs, essentially. So there's one way of passing data to the server. There's another way, just making it part of the path. That's sort of the more what we call the RESTful way of doing it. You'll see a lot of this kind of format in the REST world. All of this stuff still works as well. This is another example of a query string, but with multiple name-value pairs. So the query string starts with a question mark, and ampersand separates name-value pairs, essentially. It's really doing the same thing. It's saying, I'm doing a get, I'm using the customer API, that's presumably a customer ID, and within that customer, I'd like to look at their orders, and by the way, I just want this one. So please send that order back to me. So those HTTP methods, we talked about a couple of them already. The common ones, certainly if you're using a browser or if you're dealing with SOAP web services, WCF services, you're probably doing gets and posts. Get if you're retrieving, post if you're sending, essentially. With REST, we actually use frequently two additional of the HTTP methods. We use put and we use delete as well. One of the basic principles of REST is you use HTTP explicitly, and what that means is HTTP has a way of indicating you would like to delete something. So let's use it. So if we're asking the server to delete a resource, we use the delete method. What REST does is post, in SOAP services, post just means you're sending something. Whether you're creating or updating, there'll be some part of that SOAP message will say, this is the operation, I want to call a create or an update within the data. With REST, it's all based on the HTTP method that's used. So post is creating something in the RESTful world, and put is altering the state or updating something. So these four HTTP operations give us our basic CRUD functionality, right? Create, read, update, delete. And that's how we do this in the RESTful world. We do a get, a post, a put, or a delete. There are various other HTTP methods. One of the, in particular, head sometimes comes into play in the RESTful world. What a head request does is it's intended to be a way of you finding out a little bit of information about what would happen if you were to call a request. So for example, if you do a GET request for /customer/5/orders, you've really no idea how much data is going to come back from that call. So ahead to that same request, the idea is it would come back with the header of the response, but not the body. So, and the header of the response would probably include a header that says content length 15,400. So a head request is, in theory, a way of finding out how much data would come back were I to make this GET request. I've seen it implemented by a few web services. Not enough, unfortunately, because it is a very useful thing. HTTP request headers. So we've talked about the request line. Next comes headers. Headers are a collection of name-value pairs that essentially you're just sending qualifying information to the server. It tends to be sort of metadata type stuff, not actual application data. It's environmental stuff that you're sending typically. The headers immediately follow the request line. Each is colon separated, so it's a name of a header, colon, and its value, and then carriage return line feed terminated at the end of the header. And then essentially there's a blank line at the end of the headers, so an extra carriage return line feed. Header names generally are fairly descriptive. There is a list of a couple of hundred what are considered standard headers. There are a few standard headers that are defined in the HTTP spec itself, and then there's a whole bunch of ones that have become de facto standards over the years that are fairly well documented and accepted these days. But you can just use it for anything. You can just invent your own as well and have totally custom headers. Header values are just a variable length blob of data. So whatever you want to send, terminated by a carriage return line feed. So there's an example of a request header. This is one of the standard ones, content-type. So the HTTP spec requires that if you're sending data to the server, you have to identify to the server the type of data that you're sending to it. So basically every post or put request requires a content type header that identifies the MIME type. If you've ever done email attachments, it's the same kind of thing. It's text/XML or application/XML or text/PDF or whatever it is. And sometimes the character set, if you're using different character sets, you can include on there. So that's just an example of a header. Content type is text HTML in this case. There is one mandatory request header. So content type is mandatory for puts and posts. But there is one request header that is mandatory for every call, and that is the host header. So every request you make has to have a host header. Most tools will just insert this stuff automatically for you. And essentially, it's the name or IP address of the server that you're communicating with. And it's used to validate that requests are being sent to the right place, essentially. So it might be host:/www.google.com. That's the host you're communicating with. And that's why you don't tend to see the host in the request line. The request line, back in HTTP 1.0, it was fairly common to put the whole URL in the request line. In 1.1, you tend to use the host header and just specify the path to the resource in the request. So the host header is identifying the server you're trying to send the request to. And then these are some common standard ones. Content type we talked about. Content type is used in both directions. If you're doing a put or a post, you have to send a content type header to identify the type of data you're sending. But if you get a response back from a server with some data in it, it will have a content type header that tells you the type of data that's in the response that came back. And again, it'll tell you it's XML, it's HTML, it's a JPEG file, it's whatever it happens to be. And also content length. When you get a response back from a server, I don't think this is actually in the spec, but I think pretty much all web servers that I've ever seen implement it. And there'll be a content-length header that tells you the exact length of the data that's in the body that just got sent back to you. There is also another header that is fairly commonly used in requests, and that is called accept. So accept is your way of identifying to the server what type of data you would like to receive. So if you're calling a web service, most web services inherently can deal with usually XML and JSON, and quite often other formats as well, comma-separated values, HTTP, form encoded, whatever. So accept is your way of saying to the server, I'd like you to send me XML, please, or I'd like you to send me JSON, please. It's not guaranteed that it'll work, But if the server supports that type of data, it will return that type of data. There is a content negotiation that happens that we'll talk about later, and accept can specify multiple formats. So you might say accept application JSON and application XML. So your highest preference is JSON, but you will accept XML. And the server might only support XML. So it will compare what you're asking for versus what it supports, and it'll come up with the highest match, essentially. And there's also a cookie request header. So if a cookie is just a piece of data that a server sends to a client stores it, and the next time it talks to the same server, it sends the data back again. Session IDs, for example. Who are you? Have you been here before? So there's a cookie header that if you're sending cookies back to a server, you use the cookie request header. HTTP request body is just a variable length piece of data that contains whatever the content type header identifies. There's always the request line, there is always at least a host header, and then a blank line, and then the data of the actual request. It is optional. Get and delete requests do not include a body. Post and put requests do. Now you don't have to use it. You're probably breaking the rules if you don't. You're probably designing something that isn't quite right. It's not mandatory that you provide data on a post or a put, but to use the design patterns correctly, you would. So there's an example of a fully formed HTTP GET request. We're asking the server that we're talking to for something API orders and a number using HTTP 1.1. We're sending a host header that is required, which is acme.com, and we're saying, I would like you to return JSON to me, please. And it will if it can. Carriage return line feed terminates the headers, and it's a GET, so there is no body, so that's the end of the request. A post request is a little bit more complicated, as you can imagine. Here's the post. We're saying we're posting, we're sending data to you. This is the resource that we're referencing. So in RESTful terms, post is a create, and we're talking to the orders API. So we're creating an order, essentially. We must specify the host header. Who is it we're communicating with? We are sending data, so we're required to specify the type of content. We're saying the type of data in the body is application/JSON. And the content length is 108. You can send content length if you wish. Most servers don't require it. I think it's a good practice to say, I'm sending JSON and this is how long it is. And then here's the end of our headers, and then whatever the data is, this is an example of JSON formatted data, which we'll talk about in a moment. Anatomy of an HTTP response. So that's what a request looks like, period. That's it, 100%. We now know all about HTTP requests. Responses look very similar. There is a response line. That response line contains or confirms the version of HTTP that's being used for the interaction, and contains a status code that tells you, you asked me to do something, the status was, yep, I did it. Or no, I didn't, or there was an error, or not found, or there's a whole bunch of status codes that we'll talk about. Then there are response headers. There will always be response headers. And then maybe a response body. Again, depends what you were doing. If you were saying delete something, typically there won't be a response body that comes back. It'll just give you some status that says, I did it. Okay? And that's one of the big differences between REST and SOAP. In a SOAP environment, you wouldn't be using the delete method. You'd be posting a big old blob of XML about this big to say, go delete this order, please. And it would come back with another big old blob of XML, right in the middle of which would say status : true. And you'd have to parse all this XML to figure out, well, did it work or not? With REST, it just says HTTP deleted status. That's it. It's like 1 byte. So it's very, very efficient. Here are the HTTP status codes. Some of them we're probably familiar with. If I say get/orders/19327, and that order doesn't exist in the system, I'm going to get a 404 back. And that tells me not found. I don't get a big blob of SOAP that I have to parse that says false in the middle somewhere. I get a 404. So we're familiar with that. And there are categories of messages. So as we can see here, the 100 messages you don't see too often. They're purely informational. They're very rarely used. But you frequently will see messages in the 200 range, and basically anything in the 200 range is a success status. And there are several of them. There's 20, 1, 2, 3, 4, 5, 6, I think, 6 or 7 different types of successes. And we'll see what some of those are as we go through. The 300 error status codes are redirection. We don't tend to see those too much in web APIs, although we could do. They're fairly frequent with websites, and it basically means the thing you asked for is valid, but it's moved somewhere else, so make another request, and it would return a header with the new address of whatever it is. That could be the case in a web API. If maybe your API's changed, and it's no longer /something/something, you want them to go to another API. You could send a redirect response, and essentially you're saying to the client, I can do what you're asking, but you need to ask me a different way. Essentially, something changed. 400 errors are, again, very frequent. So anything in the 400 range they're called client errors. They're client error in the sense that you asked me for order number 5, and it doesn't exist, you silly client. You made a mistake. Some of them aren't really errors, so things like not found, okay? Some of them are really client errors. One of them is bad request. You sent me invalidly formatted whatever it is, so yes, the client did something wrong. But essentially, the 400 status codes are normal failures, things that you would expect to happen in the course of running a normal piece of software. Not found, it's already been deleted, I don't understand what you're asking me, that kind of thing. The 500 errors are the severe errors, the fatal errors. If you see a 500, you're dead, basically. We've all probably seen on the internet from time to time, server error 500, internal server error. You know, something fell over on the back end. It's not your fault, it's not 400, there's something wrong on the server, file not found, that kind of thing. So if you see a 500, it's definitely something's wrong on the server. Okay, so we make a request, we get a response, and the first thing we're interested in is, well, what's the status code associated with the response? So here's an example of what a response line looks like. In the response, the first line is going to be HTTP 1.1 space and the response number, and it also gives us a kind of human readable version of that as well, so that we can look at that log and see what it means. But 200 and OK are really the same thing. Status code 200 means OK. It's a normal, successful, whatever it was you asked me to do, I did it. Okay? Here's some of the common 200s. 200 OK. Again, very often with websites, you'll just get a 200 OK no matter what happens. With a web API, there is a slight difference between them. And if you want to use REST correctly, it's important which one of these you choose as a programmer. So 200 OK technically means it was successful and I am returning some data to you, is what 200 really means. Versus 201 is specifically successful. It's intended to be used with creating a new item, and no entity is returned in the body. So that's specifically what a 201 means. There is also a further requirement in the HTTP spec, and a lot of web services don't do this and really should. But essentially it says no entity is being returned in the body, but there will be a location header that gives you the URL of the thing that was just created. Okay, so that's how the client is going to learn the order number, for example, because there would be a location header that tells them the URL to go and retrieve that order that's just being created. So that's specifically how 201 is supposed to work. 202 means accepted but not processed yet. So if you're doing stuff online, batching it up for later, you know, you might have an API that accepts a whole load of orders and they get batch processed overnight or something. Then a 202 accepted would be an appropriate response. Essentially, you're saying, I have received your request, it is correctly formatted, everything looks good, but I haven't actually actioned it yet. But I will at some point. And 204 means no content. So 200 and 204 are fairly interchangeable. 200 says, yes, it worked, and I'm sending something back to you. 204 says, yes, it worked, and I'm not sending something back to you. So a 200 is a very common response to a GET, if it's successful. A 204 is a very common response to a PUT, if you're updating something. Okay, so if you're creating, you'll get a 201 if it's successful. If you're updating, you'll typically get a 204. If you're deleting, you will typically get a 204 because there's nothing coming back. It's saying, yes, I deleted it, and so on. Common client-side errors, 400 bad request. Basically means there's something about your request that I don't understand. You know, you're supposed to be passing me a such and such header and you haven't, or the format of your URL is wrong and I don't understand it, is what you're saying there. 401 unauthorized. Basically, if you've implemented some kind of authentication scheme and the client has not yet been through that authentication scheme, then essentially what you're saying is, yeah, this is a valid operation, but you don't get to use it. Forbidden is slightly different. Forbidden, basically, unauthorized means what it says. You have not yet authorized and you need to. Forbidden suggests that you have authorized, but you still don't get to access this thing. You're being excluded from this particular operation for whatever reason. And not found, obviously, is a fairly common one as well. You just requested something that's just not there. There are a few other 200s and 400s and so on, but these are the common ones. The 500 ones pretty much all mean there's a serious problem somewhere. 500 internal server error, just something bad happened on the server, and you could try making the request again, but chances are you'll probably get the same response. There's a configuration error, the database is down. 500 is an unhandled error, basically. You should never see a 500 in a browser or from a web service. If you see a 500, some developer didn't do their job right, because it's an untrapped error, basically. 501 not implemented, you'll see that occasionally. Typically, as you're building out new APIs, you might well flesh out the whole API first and just throw a not implemented exception for each of the operations, and then go through and sort of implement the code as you go kind of thing. So that tends to be a transient thing during development. And 503 service unavailable is what should be a structured response if the server's been taken down for maintenance or whatever it is. So a lot of environments will have some kind of switch that they can be thrown in software that just responds 503 to everything, and so on. Response headers are very much like request headers. They are name-value pairs separated by colons, and they're providing information back to the client from the server. Again, it tends to be metadata, not application data. You know, application data belongs in the response body, but it might be the length of something, the type of something. It might be how many. You know, one of the things I try and do sometimes is if I'm implementing a call that says, go get me all the orders for this customer, I like to include a item count header or something like that, so you can just take a quick peek at the headers and without having to, you know, before you parse the response, knowing there's 58 of them or something like that. So that's a fairly common use of a response header. Very common ones that you will pretty much always see. Content type is basically indicating the type of data coming back to you. Content length, pretty much all web servers implement this, so it will tell you how long is the data in the body. Location is that one that we mentioned earlier that I've seen this not implemented more often than I've seen it implemented, and it's a shame. It basically says you've just created something, here's the resource identifier that would let you retrieve it. And set cookie is a way of the server saying to the client, please persist this value, here's a cookie for you, you need to send it back to me if you talk to me again using the cookie request header. So if you are implementing ongoing sessions or something like that, you would return some kind of session ID and then send it back with a cookie header in subsequent requests. So that's an example of a GET request and response. So we're doing a GET to a site identified by the host. We're calling API orders and an order number, and the response we get back is HTTP 1.1 200 OK. So it's a successful response, and I am sending data. By the way, I'm sending you JSON, and it's 107 bytes long. And then there's the end of the headers, and there is the response data. This is exactly what RESTful web services look like. This is what we're going to be building, and this is what we're going to be implementing through the day. There's an example of a delete request. So we're saying delete API orders and an order number. We have the required host header that identifies who we're talking to. And the response we get back is simply HTTP 204 no content. 204, remember, is a success status, but I'm not sending any data back. So yes, the delete was successful. How much more efficient is that than receiving 5K of SOAP and having to parse it out to get to that one little true or false in the middle somewhere that says, did it get deleted or not? Visualizing HTTP messages, the examples we've been going through, as I mentioned already, are actually what it looks like. If you physically look at the traffic that's going over the network, that's what it looks like. Request line, headers, body, and so on. If you want to visualize it even further, using the Synergy HTTP API, just doing an HTTP GET of a URL and passing whatever headers you need, and with the log parameter, the log files you get out of the HTTP API will look exactly like this. So it's a great way of figuring out what's going on, is just to look at the actual log and see what the issue is, see what the response is that's coming back. There are also some very good tools that you can use. There's a tool out there called Fiddler. What Fiddler lets you do is, again, construct requests and responses and analyze data. It's kind of a web debugging tool that runs inside a browser. I like this one. I like this thing called Postman, and I'll demonstrate it to you later. I like it because it's simple. It's simple, but it's flexible. It does everything I need it to do, but Fiddler is kind of it's the 600-pound gorilla. It's enormous. It can do all kinds of stuff, and it's very, very capable, but it's pretty complex as well. This just makes it so simple, and you'll see it in action. By the way, there's an example of what a request and response looks like with XML data. It's exactly the same thing. It's just that the content type of the data being sent identifies, well, it's XML data, and the data is XML, not JSON. In the RESTful web services world, pretty much most implementations will happily deal with XML or JSON. But what you will typically find is that for any given piece of data, the JSON is 30, 40, 50% of the size of the XML data. Purely for performance reasons, JSON is the data format of choice in the RESTful web services world. HTTP and the persistence of state, I just want to mention one more time because it's important, is that HTTP is a totally stateless protocol. Client makes a request, server makes a response, that's it. The server has no knowledge that that client was ever there. As soon as that response is done, it's done. And it might be software that's running on the server in the ASP.NET environment is manipulating cookies to make it look like the server knows it's there. But at an HTTP level, there is no such thing as state. Some frameworks implement it. If you are going to be developing a RESTful web service, one of the absolute requirements is that you are stateless. If you're not stateless, you're not RESTful. So you're not following the rules. And that is not one of the rules that people tend to break. Okay? RESTful web services tend to be stateless. So you're going to be designing single-shot things for everything and doing whatever you need to do everything within that one call, not relying on subsequent calls, not persisting data. Now, that's not to say you can't maintain state in other ways, okay? But within the web server itself, you're not going to do it. You could absolutely say, oh, this client just did something and record some state in a database or in a file and put together some unique ID that points back to that, send it as a cookie back to the client, and the client can send it back to you and you can reinstate that environment for the next call, but the environment is gone in the meantime, okay? It's not the same thing as ASP.NET sessions, for example, in WCF or in ASP.NET web services.